Hello, future engineers, students, subscribers, and viewers. Here is another video in dynamics, particularly on kinematics of particles. I hope that through this sample problem video, your knowledge in dynamics will increase and the techniques and understanding will grow. And I hope that you will succeed in your current chosen engineering fields. Thereby, this video will help you prepare for your engineering needs. So here is the problem. The motion of a particle is defined by the relation x equals t squared minus quantity t minus 2 cubed, where x and t are expressed in meters and seconds respectively. So determine letter A, the two positions at which the velocity is 0, and letter B, the total distance traveled by the particle from t equals 0 to t equals 4 seconds. So for the two positions at which the velocity is 0, so we are obliged to set up or derive the expression for velocity and set it to 0 and solve for the time. Then the total distance traveled by the particle from t equals 0 to t equals 4, so we need to determine the positions of the particle from t equals 4 and from t equals 0 to t equals 4, and those time where the velocity is 0, because at these periods of times where the velocity is 0, the particle changes directions, and we trace the path of the particle from t equals 0 to t equals 4 so that we can analyze the total distance traveled by the particle. So as I said, first we set up the formula for the velocity. We differentiate x with respect to time, and it is equal to x is t squared minus quantity t minus 2 cubed. So dx dt, velocity is 2t minus 3 quantity t minus 2 square times 1. So because the variable is t. So v dx dt equals 2t minus 3 times quantity t minus 2 squared times 1. Simplifying and equate it to 0, so v is 2t minus 3 times t squared minus 4t plus 4. We expand the expression inside this parenthesis. So distribute and simplify. V is 2t minus 3t squared plus 12t minus 12 equals 0. So v equals negative 3t squared plus 14t minus 12 equals 0. So this problem is calculator aided. Instead of applying the quadratic formula, we have to use your calculator in finding the periods of time where velocity is 0. And t is 1.1315 seconds and 3.5352 seconds. So there are two periods of times within this t equals 0, t equals 4. So we should be careful in locating the position of the particle at these two periods of times. So the two positions for which velocity is 0 is x sub 1.1315. We substitute t equals 1.1315 here and evaluate this expression, position. And using your calculator also, 1.1315 squared minus quantity 1.1315 minus 2 cubed. And that is equal to 1.935 meters. For the other position, x sub 3.5352, so 3.5352 square minus quantity 3 minus 5352 minus 2 cube, and that would be equal to 8.879 meters. Then next is the total distance traveled by the particle from t equals 0 to t equals 4. So we evaluate the position of the particle for t equals 0, t equals 1, t equals 1.1315, take note, t equals 2, t equals 3, 3 equals 3.5352, then lastly t is 4. So when t is 0, 0 minus d, so substitute here x sub 0, this is the position vector or position of the particle rather. So x sub 0 is 0 square minus quantity 0 minus 2 cube, and that is equal to positive 8 meters. So the particle initially was 8 meters to the right of the origin. Then when x is 1, substitute to 1, 1 square minus quantity 1 minus 2 cube is 0. Sorry, 2 rather, because this is negative 1, negative 1 is 1 plus 1, so 2 meters. Then x is 1.1315, so 1.935, take note. Then x is 2, so x is 2, 2 square minus quantity 2 minus 2 cube is 4, so x sub 2 is 4 meters. Then next x is 3, so when x is 3, 3 square minus quantity 3 minus 2 cube, that's 3 minus 1, 3 square minus 1, so 8, goes back to 8 meters. Then when x is 3.5352, take note, the particle is at 8.879 meters to the right of the origin. Then lastly, when x is 4, x sub 4 is 4 square minus quantity 4 minus 2 cube. And this is 8, 16, 16 minus 8 is 8. So x sub 4 is 8 meters. We then trace the motion of the particle at these positions and time. So we plot. So these are the values. We have 0, 1.935 meters. 2, we have 4, we have 8, and 8.879 when time is 3.5352. So when time is 0, the particle was at 8 meters, so it was here. Then when time is 1 second, it proceeds to 2. So from 8 to 2. Then when time is, so distance equals 6 from 8 to 2. So let's update the movement of the particle from position 8 to position 2. That's quantity 8 minus 2, so 6 meters distance traveled by the particle. Then from 1 second to 1.1315, at 1.1315 the particle is here, so the particle proceeded to move to the left, and that is 2 to 1.935. So that distance is quantity 2 minus 1.935, so plus 2 minus 1.935 meter. Then from 1.935 meter, remember the particle is at rest here, so it changes direction. So from 1.135 seconds to 2 seconds, it proceeded to 4, so it goes back to the right to 4 as shown, and that distance is quantity 4 minus 1.935, so plus quantity 4 minus 1.935 meters. So this is when time is 2 seconds. Then from 2 seconds to 3 seconds, so from 4 to 8, and the distance traveled by the particle from this position to that position is 4, where 4 is 8 minus 4. So I'll put it quantity 8 minus 4. Then this is time equals 3 seconds. 3 to 3.5352 seconds, the particle changes direction, proceeded rather to 8.879, and the distance traveled by the particle from this position to that position is quantity 8.879 minus 8, or simply 0.879. Then finally, take note that the particle changes direction here. The particle is at rest from 3.5352 seconds to 4 seconds, it went back to 8 seconds. And again, the distance traveled is again 0.879. So plus 0.879. So this is the path traced by the particle from 0 second to 4 seconds. And this is the distance traveled by the particle. So the distance traveled by the particle is 13.888 meters. So that's all for this video. I hope that you were able to follow, understand my explanations and the solutions.